Welcome to solverfy.
In the given problem, we have an electron which is trapped in a one-dimensional finite potential well. The electron is present in the ground state. Let's say it's n equal to 1. Because the ground state energy is not equal to 0, you should not draw it at the base. So that's wrong. So that's why I've taken this as the base and this is the ground state energy, n equal to 1. We need to find out the probability of finding the electron at certain locations. So let's take the first one, A, between x equal to 0 and x equal to 0.25 L. In this case, let's say this is 0 and this is L, and the entire variable is x. So we have x as our variable. The probability density is defined as mod square of the wave function. In our case, for the electron in a one-dimensional potential well, the wave function is given as root 2 over L sine n pi x over L. Since n is equal to 1, I can simply say the wave function is psi of x equal to 2 over L sine pi x over L. Now let's try to find out the probability for the first case. So this is A. The net probability should be equal to, we need to integrate this. So we integrate from 0 to 0.25 of L over psi square, which is the square of the function, that is nothing but sine square n pi x over L dx. We have to integrate because as we see, the probability is dependent upon the variable x, because psi is dependent upon the variable x. The wave function is dependent upon variable x. So in order to find the net probability between 0 and 0.25, we have to integrate. Now we can either evaluate it easily or we can try to make a substitution. So let's make a substitution of n pi x over L. Let us say that this is equal to y. In our case, n is equal to 1, so I'll write this as pi x over L. In this case, then dy should be equal to, these two are constants, so it will simply be pi over L of dx. So dx is equal to L over pi dy. So integral now becomes 2 over L. This dx, we have to substitute for dx as L over pi. So we have a L divided by a pi. Integrate over 0, because if I substitute for x is equal to 0, y is also 0. But if I substitute for x is equal to 0.25 L, which is L over 4, I get y as equal to pi over 4. And inside I get sine square y dy. Now we can integrate this, and then the value that we get is 4.09 L, where the value is defined by L. Now similarly we can do the calculation for the next part, which requires from 0.75 L to this. So this is between 0.75 L to x equal to L. Now before we start doing all the calculations, let us realize that 0.75 L to x is equal to L Isn't this similar to x equal to L to 0.25 L, because x is equal to 0 and x in this case is L over 4. So that means it's between this point and 1 over 4. If this is half, this is 1 over 4. So this region is A. And if I look at B, which is 0.75 L, this is 3 over 4 L. So this is half, then this should be 3 over 4, then this is 3 over 4 L and L. So these are entirely symmetrical, and because a wave function is sine and sine is symmetric function, in that case the probability that you have between 0 and L over 4 should be same as probability between 3 L over 4 and L. So we should directly write that this value is also equal to 0.09 L. Here we have argued purely on the basis of symmetry. For the last section, we have x as L over 4 to x, which is 3 over 4L. Now again, we do not need to make any calculations. This is between L over 4 and 3L over 4. That is L over 4 and 3L over 4, all of this region. Now we already know that the electron will either be between 0, it has to be between 0 and L. So the net probability of finding electron between 0 and L is equal to 1. You will always find electron somewhere between 0 and 1. The probability of finding electron between 0 and L by 4, L over 4 is 0.09 L. And the probability of finding electron between 3L over 4 and L is also 0.09 L. If I add these two probabilities, I get 0.18 L. And I know that the overall probability of finding the electron between 0 and L should be equal to 1. So the probability of finding electron between L over 4 and 3L over 4, which is the remaining, should be equal to 1 minus the sum of these two, as you can see from the diagram. So I can simply say that this probability should be equal to 1 minus, I'll write this separately, 0.09 L minus 0.09 L. And what is it? That's equal to 0.82 L. So again, we have made use of symmetry. To prove this, we made use of symmetry, and to prove this one, we made use of the fact that the electron should be there somewhere between 0 and L. So the net probability is 1, which is this, and the probability of finding it in the remaining region should be the subtraction of 1 minus the other probabilities. I should erase this probably.